Hey there! In this video, I'll share with you an effective method to explain the factors affecting the rate of a chemical reaction. I'm Orlando Broomfield from Chemistry Core. Let's solve this chemistry exam style question together. An observation of this rate of reaction graph shows that the curve for reaction Y is steeper than the curve for reaction X, which means that the rate of reaction is faster in reaction Y than in reaction X. Watch this video for a much deeper analysis of this rate of reaction graph that explains the difference in the rates of reaction Y and reaction X using 4 points of comparison. Now let's discuss the 4 factors that could have caused the rate of reaction Y to be higher than the rate of reaction X. The first point is an increase in temperature. Now, if reaction Y is occurring at a higher temperature, that means the reactant particles have more kinetic energy. And with a greater amount of kinetic energy, the particles are moving faster and with more energy, so that increases the chance of collision in the right orientation of the reactant particles. So that increases the chance of collision with the right orientation, and that increases the rate of the reaction. The second factor that could have increased the rate of reaction Y above the rate of reaction X is an increase in surface area. With an increase in surface area, more reactant particles are exposed. And let's take an example to make this even clearer. Imagine that magnesium is one of the reactants in the reaction. We can have 2 forms of magnesium: magnesium powder or magnesium ribbon. With magnesium powder, more particles are exposed, so that increases the chance of collision and therefore increases the reaction rate. But in the case of the ribbon, only the surface particles are exposed to other reactants in the reaction, and the inner magnesium particles in the ribbon have to basically wait their turn to be exposed to the other particles. So an increase in the surface area increases the exposure of the particles and also increases the chance of collision of the particles, so they can be changed into products at a faster rate. The third factor that could have caused the rate of reaction for reaction Y to be higher than that of reaction X is concentration. So a higher concentration would be a factor if one of the reactants were a solution where there is a high ratio of solute particles to solvent particles. That would mean there are more reactant particles than if the solution were dilute, which means there would be a lower ratio of solute to solvent particles. And with more reactant particles, there is an increased chance of collision, and that would in turn increase the rate of the reaction. The final factor that could have caused an increase in the rate of reaction Y above the rate of reaction X is if a catalyst were used. A catalyst is a substance that alters the rate of a reaction without being chemically changed in the process, which means it can be reused. Now, a catalyst would increase the rate of a reaction by creating an alternate pathway for the reaction to occur, where that alternate pathway a lower activation energy, the minimum amount of energy required for reactants to be converted into products. So if we have a catalyst that would create an alternate pathway for the reaction to occur, and that alternate pathway would have a lower activation